Hello everyone, let's talk about another easy problem on Leetcode today. Height checker, Leetcode 1051. It states that a school is trying to take an annual photo of all the students. The students are asked to stand in a single file line in non-decreasing order by height. Let this ordering be represented by the integer array expected, where expected I is expected height of the ith student in line. We are given an integer array heights representing the current order that the students are standing in. Each height I is the height of the ith student in line. It is zero index. Then we have to return number of indices where height I is not equal to expected I. Then they have given some examples as well. In example 1, we can see that our input array is 1, 1, 4, 2, 1, 3, and our expected array is 1, 1, 1, 2, 3, 4. So we can see that 4, 1, and 3 don't match in the heights array, and that's why we have to return 3 in this case. Now let's jump into the solution space. The easiest solution is what they say. So we will just sort the array and compare the indices where the values in the sorted array don't match. And whenever we find such indices, we will just increment our count. And in the end, that will be our answer and we will return that. The code for that is very simple. So we just sort the array and then just loop on this expected array. And wherever the values don't match, we will just increment the count there and return the value. This is the input heights array and this is the expected array. And now we loop on the expected array. And whenever the values don't match, we increment the count. Like 4 and 1 don't match, 1 and 3 don't match, and 3 and 4 don't match. So indices 2, 4, 5 in total don't match, and that is our answer. So we return 3 in this case. The time complexity in this case would be O of n log n time because we are using inbuilt sort method in Java, which is like a quick sort algorithm for the primitive types. And then we again loop on the array that takes O of n time, but overall the time complexity stays O of n log n. This is a good enough solution, but the question is, can we do better? And the answer is yes, we can actually use Bucketsort because Bucketsort has a time complexity of O(n), so we can actually take the advantage of it. But Bucketsort can also be a problem because it adds to the complexity. Plus, when we have to fill in the bucket for so many integers, it again becomes slower than Quicksort, even though asymptotically it is faster than Quicksort. But in our problem, if we look at constraints, height array length is actually less than equal to 100 and the values in it are also between 1 and 100. So that means we can actually create a bucket of 101 because we want to ignore the 0th element because height cannot be 0. Now let's see how the bucket sort will work. The first thing we have to do is like we have to define the buckets from 0 to 101, right? And 0 will not be used because height of size 0 does not exist. The bucket sort is basically we create the buckets of integers, and whenever we see the same value at a particular index, we will just increment the value here. So we can see that 1 occurs 3 times in the given array. So bucket 1 will have 3 ones. Similarly 2 occurs once. So bucket 2 will have only one integer. Then 3 occurs once. So bucket 3 will have only one integer. So basically we fill in the frequency of integers in the respective index, and then once we have those buckets, either what we can do is we can just recreate the sorted array. So basically we see that, okay, 1 occurs once, so we can just write 1, 1, 1. Then we see that 2 occurs once as well. So we will just add 2 to it. Then we see 3 occurs once, so we will add 3 to the array. And then 4 occurs once, and then we will add 4 to the array. So this will be our sorted array, and then we can use the approach similar to the previous approach. But in this case, what we have to do is we have to again first create a buckets array of size 101, and then we have to again create a new array of size n, which is same as the heights array size. And after sorting, the rest of the code can stay the same. But actually, we don't have to create this whole sorted array. How about we can actually use the buckets array and use some kind of a two-pointer approach where one pointer will be pointing to heights array and another pointer will be iterating on the buckets array, and we will just compare the values one by one, similarly to how we were creating the array here. Let's jump into the example to understand that part. So initially, we will have the heights like this and bucket of up to 101. I've just removed the indexes for the clarity, but I hope this is now clear. So when we are at I equal to 0 and iterated j equal to 1, so j is actually the height because the indexes in the buckets are actually the heights and the values in it is the frequency. So initially j will be equal to 1 because height cannot be 0. So initial height for us will be equal to 1. And we will start from the 0th element in the array. We can see that ith height, that is 1, is actually equal to j, which is also equal to 1. So that means there is no mismatch this time, but we still used one of the frequencies of jth bucket, right? So we will decrement that frequency by 1. So now value at j becomes 2. Now height I is equal to 1 and j is still equal to 1, right? Because we still have two ones remaining that we have to process. And we see does heights I match to bucket j? And answer is yes. So we will just decrement the counter in the bucket by 1 and go to the next I or next value in the heights array. And this time we see ith height is now 4 and bucket still have one element remaining for height 1. So we see that heights don't match. That's why we now increment our count from 0 to 1 and decrement the bucket again because we use this one as well. So now we have used all the ones and we have no ones remaining. Now we go to the next iteration. And now I is equal to 3 and j is still equal to 1 even though the value became 0. So now we have to find some non-zero bucket by traversing in this direction so that we can match the non-empty height. So we see, okay, we already have height equal to 2. So we still have 1, 2 remaining, which we can use. And what is ith height right now? It is also 2. So they actually match. We actually use this j equal to 2. So we will reduce this value from the bucket. And now we don't have any 2 remaining. So now our I increases again. And now heights is equal to 1. And bucket's value is 0. So we again find some non-zero bucket. So our bucket, luckily we found 3 next to it. So now j is equal to 3 and we have only one count remaining of it, but heights don't match. So we will just increment the counter by 1 and decrement the value in the bucket because now we have used this 3 as well. Now we again increment I, that is now we are at the last iteration. This should be I equal to 5, not 4. We are at the last iteration. So we see that value here is 3 and we are at the bucket which is 0 right now. We don't have any value for 3 remaining, right? So we will actually increment the bucket value to find the next non-zero bucket. And luckily it was next to it, j equal to 4. And we see is 4 equal to height 3 and the answer is no. So we will again increment the count and now our count becomes 3 and we decrement the value of bucket here. So notice that now whole of bucket arrays become 0 and we are also at the end of the loop. So we will just exit and finally our result is equal to 3 and that is what we will return. I hope this algorithm was clear. Now let's jump into the code part. So first thing we will define is the buckets. Now we will just fill in these buckets with different heights. Now we will just have our counter. We can say it as answer equal to 0 and our initial bucket value will be j equal to 1 because of the constraint the minimum height is 1. And now we will start iterating on the heights array. So second thing we have to do is we have to find the non-empty bucket. In the example that we covered, luckily we had 3 ones, so we don't have to worry about it. But we may not have one present in the array at all. Till we don't have any non-zero height present in the bucket, we will just loop and move towards rightwards till we find some non-zero height. And now we will just check if the jth height is not equal to height I, we will increment our answer. And in any case, we will just decrement the bucket value or bucket frequency by 1. And in the end, we will just return our answer. Let's run this code. It should be buckets, yeah. Hopefully that's the only problem. Let's run the code again. Cool. Let's submit the code. Awesome. So we actually beat 100% of the people, but I think in terms of time complexity, it takes O of 101 time to actually build this buckets array and then O of n time to actually loop over the heights array. So in terms of time complexity, it will be O of n, and in terms of space complexity, it will be O of 101 because technically, which is also equal to O of n given the constraint. I hope this video was useful to you. If it was, please like and subscribe. The code link is in the video description. Thanks again.